Jupiter is the largest planet in our solar system. It's so big that you could fit 1,300 Earths inside it and still have room left over. The planet stretches more than 11 times wider than Earth, and it weighs 318 times more than our entire planet. It's a world of extremes with no solid surface to stand on, and storms that rage for centuries, and the Great Red Spot is a hurricane so large that 3 Earths could fit inside it, and the storm has been raging for at least 400 years and maybe much longer than that. In our solar system, Jupiter is king, and nothing else even comes close. But astronomers have found something bigger. Far beyond our solar system, 1,200 light-years away, there's a planet that makes Jupiter look small. When scientists first measured its size, they couldn't believe what they were seeing, and they had to check their calculations multiple times because the numbers seemed impossible. This planet is roughly 150,000 kilometers wide, about twice the size of Jupiter, the largest planet ever discovered by radius in the entire universe. But when they measured how much it weighed, something was very wrong. The planet is called HAT P67b, and it sits in the constellation Hercules, and it orbits a star much hotter and brighter than our Sun. And despite being twice Jupiter's width, it weighs less than half as much. Scientists measured its mass at just 0.34 times that of Jupiter, and that creates a mathematical problem that shouldn't exist in nature. When they calculated the density, the numbers got even stranger. The planet has a density of just 0.061 grams per cubic centimeter. To put that in perspective, a marshmallow has a density of about 0.2 to 0.3 grams per cubic centimeter. This planet is less dense than a marshmallow, and it's less dense than styrofoam, and it's even less dense than some types of aerogel, which is one of the lightest solid materials we know how to make. If you could somehow place this planet in an ocean large enough to hold it, the planet would float like a beach ball. Astronomers call it a puffy planet, and it's not just big and light. There's something else happening to it that makes it even more bizarre. The planet is surrounded by a massive cloud of gas that extends far beyond its surface and stretches up to 6 times the size of Jupiter, and this cloud isn't stable or permanent. It's actively being ripped away from the planet and blasted into deep space. Telescopes have detected hydrogen and helium pouring off the planet in a continuous stream, and scientists measured the rate of this gas loss and found something shocking. The planet is losing about 10 million tons of gas every single second. Think about that for a moment. Every second, 10 million tons of the atmosphere is being stripped away and blasted into space. That's the weight of about 1,500 Eiffel Towers being ripped off the planet every single second. And in 1 hour, the planet loses enough gas to equal the weight of 54 million Eiffel Towers. And in 1 day, it loses the equivalent of 1.3 billion Eiffel Towers worth of atmosphere. The escaping gas forms a tail, just like a comet, and astronomers have detected both a leading tail and a trailing tail, with more mass being lost from the side facing its star, and the tails stretch for hundreds of thousands of kilometers into space. This isn't a stable world. It's a planet actively tearing itself apart. And this creates a paradox that scientists are still trying to understand. The planet is enormous, but it's also incredibly fragile. Its gravity isn't strong enough to hold onto its outer atmosphere, and as the gas escapes, the planet gets lighter and lighter, and the process accelerates because the less mass it has, the weaker its gravity becomes, and the easier it is for more gas to break free. It's a death spiral, and it's happening right now, and there's no way to stop it. The real mystery is the structure of the planet itself. When you compress gas, it's supposed to get denser. That's basic physics. You can test this yourself by squeezing a balloon and feeling it get harder as you push the air molecules closer together. Jupiter is massive because it's packed with gas compressed by its own gravity, and all that compression makes the planet incredibly dense for something made of gas. But this planet is twice Jupiter's size, with less than half its mass, which means the gas isn't being compressed the way it should be, and something is pushing back against gravity and keeping the planet inflated like a balloon that's about to pop. And that something is heat. But not just any heat. We're talking about temperatures so extreme that they fundamentally change how matter behaves and turn gas into something that barely resembles the air we breathe. And to understand how this planet became so impossibly light, you have to understand where it lives and what's happening to it every single day, and why its location is both the reason it exists and the reason it's dying. The planet orbits incredibly close to its star, and that star is hotter and brighter than our sun. The star shines about 12 times brighter and is roughly 2.5 times larger, and it's burning through its fuel at a much faster rate than our sun does. And the planet doesn't orbit at a safe distance like Earth does around our sun. It orbits at just 0.065 astronomical units away from its star. To give you some context, that's about 10 million kilometers. That might sound far, but it's actually incredibly close when you're talking about the distances in space. Mercury is the closest planet to our sun, and it orbits at 0.39 astronomical units, and Mercury is already close enough that temperatures on its surface can reach 430 degrees Celsius during the day. This planet orbits 6 times closer to its star than Mercury does to the sun. At that distance, the planet is being absolutely roasted, and there's no escape from the heat and radiation. Because it's so close, the planet completes one full orbit in less than 5 days. That means a year on this planet lasts less than a work week on Earth. Just 4.8 days. And during those 4.8 days, the planet is being blasted with intense radiation and heat from every direction, and there's no night side where things cool down because the planet is tidally locked, which means one side always faces the star, just like how one side of our moon always faces Earth. The surface temperature on the star-facing side reaches around 1,900 Kelvin, which is about 1,630 degrees Celsius. Hot enough to melt metal, and hot enough to vaporize rock, and hot enough to turn solid materials into gas almost instantly. This extreme heat is what created the puffy planet in the first place. The planet belongs to a category called hot Jupiters. And these are gas giants that orbit extremely close to their stars, and they're actually pretty rare in the universe. In our own solar system, all the gas giants orbit far away from the sun, where it's cold and stable. Jupiter is 5.2 astronomical units from the sun, and Saturn is 9.5, and Uranus is 19, and Neptune is 30. They formed out in the cold regions of the solar system where ice and gas could accumulate without being blasted away by solar radiation. But hot Jupiters are different. They're massive gas giants orbiting closer to their stars than Mercury orbits our sun, and because of that proximity, they absorb massive amounts of energy. That energy heats the atmosphere and causes the gas to expand. The planet swells up like a balloon that's being inflated, and the hotter it gets, the more it swells, and the process continues until the planet reaches a breaking point. Scientists call this the hot Jupiter inflation effect. The closer a planet orbits to its star, the more energy it absorbs and the more it expands. For most hot Jupiters, this inflation effect creates planets that are bigger than expected, but still relatively stable, and they maintain their atmospheres and orbit their stars for billions of years without any major problems. But this planet pushes the effect to an extreme that we've never seen before. The star's radiation doesn't just heat the atmosphere, it ionizes the gas, and that means it strips away electrons and supercharges the outer layers. When gas gets ionized, it becomes electrically charged, and it behaves differently than normal gas. It's lighter, and it's easier to blow away, and the star's radiation is constantly pushing it out into space like a wind that never stops blowing. The result is a planet that has expanded so much that its atmosphere is barely held together by gravity, and the outer layers are so far from the planet's core that gravity can't hold them down anymore. And that's why the gas is escaping. The gravity isn't strong enough to hold onto the outer atmosphere while being bombarded by this level of radiation and heat. So every second, millions of tons of hydrogen and helium break free and stream into space, and the planet gets lighter and the process gets faster and faster. And there's no way to stop it, because the star keeps pumping out radiation and the planet keeps swelling and losing mass. And this isn't just unusual, it's a death sentence. The planet isn't just losing gas, it's losing its future. And scientists can predict exactly when it will die. Planets like this one are not supposed to survive for very long. Scientists have calculated that planets with this level of atmospheric loss should completely strip away their atmospheres in less than 100 million years, and that sounds like a long time, but in cosmic terms, it's barely a blink. The universe is 13.8 billion years old, and our sun has been shining for 4.6 billion years, and will continue shining for another 5 billion years before it dies. So 100 million years is nothing on that timescale. And once the atmosphere is gone, the planet becomes vulnerable to even more extreme forces. Without the protective cushion of gas around it, the planet's core gets exposed directly to the star's radiation, and that radiation starts breaking down whatever solid material is left, and eventually the core itself gets destroyed. But here's the strange part. The planet has already survived for over 1 billion years. The star it orbits is relatively young, but the planet has been around long enough that it shouldn't still have an atmosphere. By all calculations, it should have lost its gas envelope hundreds of millions of years ago, and it should be nothing but a dead core by now. Yet somehow, it's still here. Still massive, still losing gas, still one of the largest planets we've ever found. Nobody knows how it managed to survive this long. One theory is that the planet didn't always orbit this close to its star. Scientists believe it probably formed much farther out in a region where the temperatures were cooler and the radiation was less intense, and it could accumulate gas without losing it to the star. Over time, gravitational interactions with other objects in the system could have caused it to migrate inward. Maybe it was pulled by the gravity of another planet, or maybe the star's gravity slowly dragged it closer over millions of years. Either way, it slowly spiraled closer and closer to its star until it reached its current position. If that's true, then the planet might have spent most of its life in a stable orbit, far enough from the star to avoid losing its atmosphere, and it might have looked like a normal gas giant for billions of years. Only recently, in cosmic terms, did it move close enough for the star's radiation to start stripping away the gas. That would explain why it still has an atmosphere. We're witnessing the final chapter of this planet's life. We caught it at the exact moment it started to die, and we're watching it happen in real time. But the death spiral is accelerating. The star is evolving. Like all stars, it's slowly getting brighter over time as it burns through its fuel and the nuclear reactions in its core become more intense. And as the star gets brighter, it pumps out more radiation. That radiation heats the planet even more, which causes even more gas to escape, and the cycle repeats itself, getting worse with each passing year. The process feeds on itself. The more gas that escapes, the lighter the planet becomes, and the lighter it becomes, the easier it is for more gas to break free, and the easier it is for the star's radiation to heat what's left. Scientists have modeled the future of this planet, and the results are grim. Within the next 150 to 500 million years, the planet will lose its entire atmosphere. What's left will be a small, dense core stripped bare and exposed to the full force of the star's radiation, and that core will be incredibly hot and probably made of heavier elements like rock and metal that couldn't escape into space. And even that core won't survive for long. As the star continues to evolve, it will expand into a red giant. When that happens, the star's outer layers will reach out and engulf the planet entirely, and the temperatures will be so extreme that even solid rock will vaporize. The planet will be swallowed whole, consumed by the very star it orbits, turned into nothing but atoms scattered throughout space. In the grand timeline of the universe, this planet doesn't have much time left, and yet right now it exists. The largest planet ever found, twice the size of Jupiter, less dense than a marshmallow, dissolving into space at a rate of 10 million tons per second. It's a fragile giant held together by the thinnest threads of gravity and doomed by its proximity to a star that won't stop burning. This planet proves that size doesn't equal strength. Even the largest objects in the universe can be fragile. And sometimes we're lucky enough to witness something incredible at the exact moment before it disappears forever. Right now, 1,200 light-years away, this impossible planet is still there, losing gas, getting lighter, moving toward its final destruction. But in a few 100 million years, it will be gone. The star will consume it, and all that will remain is the data we collected, and the memory that, for a brief moment in cosmic history, the largest planet ever found was also one of the most fragile. And maybe that's the real lesson here, that the universe doesn't care about our rules or our expectations. It creates planets that shouldn't exist, and stars that burn too bright, and black holes that break our understanding of physics. And sometimes the biggest things are also the most temporary, and the most beautiful things are the ones that won't last. So, what do you think happens to the core when the atmosphere is completely stripped away? Does it survive as a hot, rocky planet, or does the star destroy it completely? Let me know in the comments. And if this changed how you think about gas giants, hit that like button and share this with someone who still thinks Jupiter is the biggest planet out there. Thanks for watching.